So this is problem 1 from chapter 19.1. And what you need to understand about terminal voltage, and once you understand that, it's actually pretty simple, is that a battery, you can think of a battery as, because here's the deal with a battery, is that as you draw current from the battery, the voltage at its terminals goes down. A real battery has something called an internal resistance. So if we draw a little dotted line around this, it's like it's a voltage source with a little bitty resistor inside there, right? And so we're supposed to say it's an EMF of 8.50 volts. So that's this guy here, right? And then it's got a internal resistance of 0.900 ohms, right? Well, that's not much resistance, but if you draw enough current, if you draw 1 amp of current, it drops this voltage 0.9 volts, right? Because of IR, right? So what they say here is they say you connect it in series with, and of course you're only connecting one resistor. You could argue it's also parallel, right? An 81 ohm resistor and an 810 ohm resistor. So for the 81 ohm resistor, the circuit looks like this, right? And all you have to do when they say find the terminal voltage is find this voltage right here. And that voltage is always going to be, it's always going to be the EMF, which is another way of saying voltage, right? It's going to be the EMF minus IR, where that's the internal resistance, right? I don't know, right? That would be like a formula, right? Is that the terminal voltage is always whatever the thing provides minus however much it drops on that resistor, right? So 81.9, there it is. Okay, so here he figures out the current, right? And then he goes, what's he doing? 8.5 minus. Don't you have to do IR then, the next thing? I think the next step is you get the current, and then you have to do that times 0.9, right? And that gives you I think, right? So he figures out the current. The current is 8.5 divided by total resistance is 81 plus 0.9. That's why it's 81.9, right? And then I think you need to go, that gives you the current, right? And then I think you need to go R, right? So 8.5 divided by 81.9 is 0.1037, et cetera, et cetera. Multiply that by 0.9, and that's the IR, right? And so it's going to be 8.5 minus 0.10378 times 0.9, right? And so I'm going to go, and I get 8.41. Ta-da. Which he largely got the same thing, right? Okay. Actually, you did that. You did that, Ben. You actually did that step because you're getting exactly what I got when I did this. So you just forgot to write it down, I think. Right? So this is actually minus 0.0934, right? And then if it's an 810 ohm resistor, you go 8.5 divided by the resistance, which is now 810 plus 0.9 is this, right? And then that gives you this. And then, yeah, here he shows that same step, right? So now it's 8.5 minus, that's the I. There's the R, right? Does that make sense? So notice the 810 ohm resistor draws much less current. The terminal voltage is much closer to the EMF of the battery. Does that make sense? But when you draw a lot of current, the voltage drops. And it's a simple model. It's not really what's going on in a battery, but it's close to it. And IBII does that. They've actually written problems. There's a problem with terminal voltage on the mock test that you're going to take. Okay, so that's the notion. Are we okay on number 3? Questions about 3? How about number 1? Are we okay on number 1? Are we okay on number 3? Yeah, let's set it up, right? Okay, so number 3 says, what is the internal resistance of a 12-volt car battery whose terminal voltage drops 8.4 volts when the starter draws 75 amps? Holy cow, okay, 75 amps. So here's this internal resistance, right? This is 12 volts, right? And I guess we don't even need to draw a circuit here, right? It's dropping 8.4 volts, and it's drawing 75 amps. So this thing here, this IR, is 8.4 volts, right? So we just basically have to set up an equation. 8.4 volts is 75 amps times the internal resistance. Yeah, that's pretty easy, isn't it? That's part one. Are we okay on part one? Right, so if it drops 8.4 volts, is that what it says? Oh, it drops to 8.4 volts. Okay, yes, we need to be observant. Okay, that doesn't work, right? So you got to do what he did, right? Okay, is he figures out that it's 3.6 that it actually drops. Is that right? Yeah, is that right? It actually drops 3.6 volts. Yeah, he's here. It actually drops 3.6 volts, and then, did you ever figure it out? Yeah, you did figure out. Is this the internal resistance that you figured out here? Yeah. Yeah, there it is, right? So all I did, the mistake I made was that you need to go 12 volts minus 8.4 is 3.6. That's how much it actually drops. That drop is equal to I times R, where that's the internal resistance. Okay. And then it says what's the resistance of the starter, and there's two ways to do this. The way I would do this is, you know that the starter is running on 8.4 volts, right? 8.4 volts, and then the current is 75 amps, isn't it? Right, so the resistance, hopefully I'll get the same answer he gets, right? But the resistance should be 8.4 volts divided by 75 amps. It should be that simple, but, you know, I'm going to retract that statement if I don't get the right answer. 0.112, okay, there you go. And you're using the formula for it, right?
Yeah, that's the formula.
That's the formula that the book gives you, right? And that's just fine. But don't you know that the starter's running on 8.4 volts?
Yeah.
So it's actually a little simpler than that, I mean, but that's okay. So basically, all you need to understand about the internal resistance of a battery is just think of the battery as this way. Put a resistor there, solve it like a series circuit, and you should be good. When they say what is the terminal voltage, they're talking about the voltage minus the voltage drop on that resistor. And you know how to find voltage drops on resistors, yes? I hope you do, because we're going to take a test on that, right? Are we okay?